So how about if we have your Kirchhoff's rule? Do you still remember how to solve this one? Okay, so we have three rules, right? We have voltage rule and current rule. Let's assign first current rule. By the way, this is also advanced for our 115 students here. Meron bang 115 students here? Yes, meron. Si Rain. Si Rain lang. Absent si Althea. Okay, sige. So this is Kirchhoff's rules. So we have two rules. Ano yung two rules? First one is your current rule or KCL. Kirchhoff's current law. Okay, wherein sum of I in a loop, in a junction, is equal to 0. So here, if the junctions are, so we have two junctions here, we only need to assign one junction. And then we can assign a specific, the direction of the current. So let's say this branch, this is the current I. At this branch, this is the current I, current 2. And then let's say here is your third current. So this will be equal to anything in is plus, anything out is minus, or vice versa. Okay, so anything in is plus, so this is I1 plus I2 minus I3 equals 0. Can somebody tell me which conservation law we used or physics law we use for or the basis of Kirchhoff's current rule? Anyone?
Conservation of energy, sir.
No.
Charge.
Okay, it should be charge. Okay, conservation of charge. So this is an equation, a linear equation with three unknowns, I1, I2, and I3. So we need two more equations to be able to solve I1, I2, and I3. So where do we get those two other equations? We get those two other equations from KVL or current voltage rule, which is based on conservation of CJ. CJ? Wala. Okay. Carlos?
Energy, sir.
Energy. Yan. Okay. So here, the sum of the voltages gain or drop from the system is equal to 0. Okay. So physically, what we have here is we have to look we have to consider a certain loop. So let's say we're going to consider these two loops. Okay, so let's call this loop number 1. And let's call this loop number 2. Okay, so by convention, we have to use the loop in the same direction. Because this is equal to 0, as long as one direction is opposite the other, that's fine with me. But let's say, let's have this direction, clockwise direction. So this, for loop number 1, so we have 1, 2, 3, 4 components. So this summation should have 4 components. So let's start with this one. So the loop is from plus to minus. So this is a voltage drop. Okay, so this is the voltage drop. So this is a negative. So this is negative 10 volts. Okay. And then this loop, resistors always, if the current is in, the current here is in this direction. Anong sign ng voltage dito? This should be 4 times I1. But the sign should be what? The sign should be
minus, sir.
This should be a minus. Okay. This side is from negative to positive. So I have a voltage gain. So this is plus 14 volts. And then the last part would be, this would be the current. The loop is in this direction. So this is a voltage gain. So this is plus 6I2. Simplifying this, we have 4I1 plus 6, minus 6I2, and then minus 4 equals 0. Sabihin nyo kung may mali ako ah. Okay, next would be this loop. So let's start with 10 volts. So the loop here is in this direction. So this is from negative to positive, so that's voltage gain, so that's plus 10. Then the loop here goes in this direction, but the current also flows in the same direction, so that is a voltage drop. So this is 6I2. And then lastly, the loop here is in this direction, but the current I3 is also in this direction, so this is voltage drop as well. So this is I3. So this is minus 2I3. This is equal to 0. Okay, so let's it should be 4. So on this side, we now have 6I2 plus 2I3 equals 10. Okay, so the matrix equation that will end up here is 1, 1, negative 1. So this is I1, I2, and I3. And this is equal to 0, 4, and 10. So this row would be 4, negative 6, 0. So third row would be 0, 6, and 2. Okay? So this will be our matrix. And then to solve this, let's just use the okay, so let's save. And then let's have another copy. Let's say Kirchhoff's sample for here Kirchhoff's. Okay, so our unknown here will be I. So let's properly label this as I. And then this will be our K. So our K would be, so we can delete this one. Our K would be 1, 1, 1, negative 1. Then 4, negative 6, 0, and 0, 6, and 2. Then for our M, this vector is 0, 4, and 10. Okay, so we don't need to use G anymore, or let's put in G equal to 1. Because this is 1 times this one. Tama, di ba? Okay. So let's display the current in each branch. are I1, first I2, second I, and I3, third I. This is the unit would be ampere, and ampere. So let's see what happens. Let's run, and this is the result. So you will notice that each current will have the same, we are all positives. So that means the assumption to the assumed directions of the current we used here are correct. If one of this is wrong, for example, if one of the currents, if one of the assumed directions of each of the current branches or branch currents is wrong, it will appear in our solution to as negative. Okay?